Now in real waves, the shape of the oscillations in the wave can be very complicated, but we often follow a really simple model where that oscillation looks like a sinusoid, so a cosine or a sine. So this axis here will be distance, and this axis here, well, that depends on what kind of wave it is. So if this is an oscillation in, say, the voltage of something inside an electrical circuit, then that will be measured in volts. If that's the height of a guitar string, then that will be measured in meters. And so the units of the amplitude of the wave, remembering that the amplitude of the wave is how high it is between its median point and the peak, so the units of the amplitude depends on what kind of wave it is. The wavelength is the distance between successive points on the cycle, so it could be peak to peak or trough to trough, and the wavelength is therefore obviously measured in meters. And because it's a wave, these oscillations are moving. So let's assume they're moving to the right, and so these peaks will be moving, the troughs will be moving, everything will be moving. And so if we just sit at one point, so if we just pick a point and sit there, then it's going to go down and up as this wave passes by. And so we're going to sort of be following this wave down just by sitting there. And so this point will come on down, and then when it gets to the bottom, when this bottom trough passes this point, then it'll be on the bottom. And when this top peak passes this point, then it'll have come right up to the top here. And so it'll also be going up and down in a sinusoidal motion. And the time it takes to go through one cycle is called one period.